Great. Welcome back. First, I'd like to thank Benedetto for inviting me to this workshop. It's really great to learn about all the work that has been done in values and from other partners. On a personal note, I actually moved back to Europe, to Paris, from the US. And it's really fascinating to see all the work that is done on ecosystem services and nature-based solutions for cities, which is what I'm focusing on now. And actually, with that in mind, I wanted to start with this picture, which I really like. Does anyone know this place? Yeah. This is in Vienna, indeed. I really love, and I actually visited the art house by Hundertwasser recently, and I was really inspired by this his idea of the three tenants in the art house, basically recognizing that trees have needs too, and that really was really visionary in that space, trying to think about all the services that we derive from nature, even in very man-made environments. And so I guess with this idea of this is not new, we have really recognized this connection to nature for a long time, but there's a lot of momentum around ecosystem services and analysis. And so what Benedetto asked me to do today was to bring some of the US, West Coast US experience and provide a bit of an overview on Invest, and in particular the work that we've done with the life cycle assessment published last year. So just before I do that, a quick word on the Natural Capital Project, my institution. So I mentioned this connection between people and nature, and this is really in our mission to better understand how these connections are made and how we can actually use them, better understand them, and do so in a way that benefits both people and nature. So we really believe in the production of information, co-production of information to better understand these relationships and find solutions that will benefit both people and nature. So we're a partnership between two NGOs, the Nature Conservancy and WWF, and three academic institutions, the Stanford University, the Chinese Academy of Sciences very recently, and the University of Minnesota. And so the way we work is, for the past 13 years almost, is really to find how this understanding of ecosystem services can help people in specific projects. So we've worked in a number of applications around the world and really addressing different types of questions in coastal environment, with the private sector, in cities as well as a newer initiative. And so I just want to go through what each point of this map, not literally each point of this map, but the general approach that we take in our projects. And this project cycle will look familiar in one way or another to many of you. So, of course, we start the project by defining the partnership and trying to understand better what the questions are and what are the issues at stake. Then we compile data, and we work a lot with spatially explicit data. We find that maps are a great way to engage with people and really find what the issues are and how we can solve them. The next step is generating scenarios. So we've talked a lot about this already in the first session, trying to find what plausible futures, positive futures, or business as usual, what they might look like. And the next step is to think about the provisioning of ecosystem services for each of these scenarios. And the last two steps are probably the most important on this diagram. Number 6 is about iterating. So once we have a first set of results, we go back and try and understand what makes sense, what does not, what should be refined or maybe ask different questions based on this first round of results. And of course, number 7, really impacting decisions. So making sure that all the great work that scientists and practitioners do is actually implemented into policy. And so just to, I guess, situate the INVEST software suite that I'm going to talk about, it really helps us take this step between the scenarios and the spatially explicit scenarios and the results. So INVEST, in a word, is one of these integrated models. And to put it simply, it helps translate these maps and variables characterizing the environment and people. So we have biophysical as well as socioeconomic data, and translate this into services maps, so things that people can relate to and that has more meaning to make decisions. So the software was developed over almost 10 years now, and I'm not going to go through the whole list of services, but these are the modules that are available on our website. So all the software is open source and free. And you can see from this list of services that we're looking at freshwater services, terrestrial as well as coastal services. So I just want to give you one example before I start presenting the LCA work. This is another project that I'm currently involved in Myanmar, and I think it illustrates kind of the steps that I just mentioned. So over there, after some conversations with the WWF, the regional office, as well as the government, these 3 services were identified as really important for the national planning policy. So we have sediment retention, seasonal water yield, and coastal vulnerability. So we've used the INVEST models and develop new approaches to think about beneficiaries as well. And then you can combine this information. So this is step number 5, I think, on my diagram, but really thinking about how to aggregate this information in a way that makes sense to policymakers. So over there, there was an interest in looking at where hotspots of services were on the landscape, and whether they overlapped with the key biodiversity areas, KBAs, to see if these were actually situated in the same place. And so, of course, you can zoom in and think about what it means for protected areas and for a particular national park, and whether this needs to have a different level of protection, for example, that the government and the environmental department should think about. So that's just a very, very high-level overview of the type of projects that we've worked on. And now I'm going to move on to the LCA project that we have conducted with Unilever, the consumer good companies, over the past three years. Yeah, I think the paper was published last year, but it was really almost a 2-year effort with them. And it's, in many regards, it's similar to the approach that was presented by Benoit and others in the first session. So I hope, well, first, thank you for the great presentations, because I think there's a lot of common background that I don't need to go through. So the 2 main questions that we had when we started the conversations with Unilever was about the commodity supply chain and whether it was dependent on ecosystem services. And they were interested in knowing if there were safe places to source from. So really thinking about their commodity supply chain and the decisions that they can make as a company to minimize the impact on the environment. So in other words, the idea was to enhance the life cycle assessment approaches that they were already using internally to better represent these environmental impacts. And I think you can already see the links between this work and the values project. So the case study that we looked at to kind of simplify things was about bioplastic, so the feedstocks, either maize or sugarcane, to make bioplastic. And so maize was sold from the US and sugarcane from Brazil. And so for these two options that they had, we looked at 5 biodiversity indicators and ecosystem services. And we did so for 3 target production volumes. Again, there was some mentions about the nonlinearities, and so they wanted to know if this target volume would actually impact the results. So the approach we developed, and I'm going to warn you, this is going to be a busy slide, but this hopefully relates to the previous presentations as well. This is the life cycle inventory with the agricultural stage here represented in yellow. And what we did was essentially look more into this box and think about a similar approach where you represent what actually goes on in the environment to think about the impacts of on ecosystem services. So if I'm actually going through here, the idea is similar to the land change models that were mentioned before, was to think about, for Brazil and the US, what does the target production mean in terms of intensification and extensification, and then run these new land use maps through the INVEST models to look at the impacts in terms of ecosystem services. So just unpacking this, and that's the only method slide that I'll have here, but this is already published, like I mentioned. The idea was to use 2 approaches for the land change modeling, recognizing as well that there are a lot of uncertainties in this first step. So we wanted to compare a logistic regression model with a more simple approach to generate scenarios and expand agriculture land on the landscape. And then, like I said, just running the black box model, so feeding these maps into the INVEST models. And so the 2 take-homes that we had from the project was, the first one was about the decisions that Unilever, in that case, would make based on this approach or the standard LCA. And the take-home here is that, yes, it would change the decision for this particular case study. So on this graph, I'm showing in red the standard LCA, and in yellow the LUCI, so the new approach, for each of the variables of interest. And on the right-hand side, there's when sugarcane has a higher impact, and on the left-hand side, when the maize decision had a higher impact on the environment. And so, as you can see, when bars go from one side to another, it means that the decision, the models did not agree on which option had the least impact. And even when they do agree, the magnitude is quite different. So really using this method, as was highlighted before, the choice of the method for the LCA really impacts the decision. The second take-home is about these nonlinearities, which was really something that our team and our colleagues at Unilever wanted to investigate. And so each of these graphs here show on the x-axis the target volumes, and on the y-axis the amount of ecosystem service per ton of bioplastic. And so obviously with a standard LCA approach, you have this characterization factor that is at the scale of the country, so you can just draw a straight line. But for some services, intuitively, ecosystems don't respond linearly. And so if you have more demand and more impact on the landscape, the standardized impact by ton will actually change as well. So that's kind of the 2 take-homes from this case study, and I think it really relates to the main messages that Benedetto was presenting earlier. The team at Unilever is working on making this workflow easier and easier as well for them internally, because that's, like I said, it was a 2-year project, so there's still a number of steps involved in this, and we're not yet at the stage where it's a simple model that anyone could run for a new company. So just before concluding, I just wanted to give you a couple of slides on what we're working on now. And one of the new projects that is pretty high priority at NetCap is around the cities work, like I mentioned. So there are multiple ways we're approaching this work on urban ecosystem services, but one of them is to expand the INVEST tool, the software tool, to include urban ecosystem services. So I'm showing here the suite for anyone working in urban ecosystem services area. These are the usual suspects when we think about the role of nature in cities. And so we're working on developing these new modules for anyone with a land use land cover map in a city, as well as biophysical and socioeconomic data to come up with these maps of ecosystem services. So I'm just showing a couple of examples. We're working in San Francisco on a project. This is the recreation service for the Bay Area in San Francisco. This is on the urban heat island in the Twin Cities in Minnesota. So same thing, looking at the effect of a golf course in that case in mitigating urban heat. And like I said, I'm just showing this slide again. The idea is to really improve this and make it easier for people to go from these maps to actual ecosystem services. So I think I'll stop here for this brief presentation. I just wanted to come back to this nice picture because I really like it, and I think by facilitating this process for researchers and practitioners, we believe that it really helped making a difference in quantifying these connections between people and nature. So happy to take any questions now, if Benedetto allows me, and yeah, thanks for listening.
Can you explain again how do you link INVEST and LCA? I didn't get very clear.
I think the key link is the land use land cover map. So I showed how from 2 different land change models we can get land use land cover maps, and this is one input, one of the key inputs into the INVEST models. So then with a different land use land cover, say with more agricultural land, the model will show that the ecosystem services amount have changed, and this is what we are using in the LCA, then plugging it back into the LCA workflow.
Okay. But then once it's plugged back, it is reused, or it's just an additional result to the LCA?
It either replaces some of the categories that were already there, or it's an additional impact that was not initially in the LCA.
Okay. And do you think that let's say the type of input data in terms of land use change that you have in LCA in the lifecycle inventory now, is it okay? Is it compatible to INVEST? It should be developed. What's the match?
Yeah, that's a great question. So we used MODIS data, so 500-meter land use and cover data, which, to my understanding, is not what the standard LCA with the Blanc tool is doing. It's per country. You have these characterization factors. So for us, we wanted to use globally available data, so MODIS is. It's not the best data, but at least you can compare it consistently across regions and within a country as well.
Any other questions?
Yes.
Okay. I'm interested in when you presented the urban ecosystem services.
when you are working on recreation, the main variables or the main factors that you consider. So you, for example, you consider that recreation depends only on the open spaces, or it depends also in the people that live around those spaces and how they can access there. So how you also how you gather this information, because sometimes it's difficult to understand, to gather information about the amount of population.
Yep. Yeah, in that case, we have the model that is available online actually uses social media data, Flickr data, so it's a biased sample, but we've done some studies looking at the correlation between this population and actual visitation rates. And so for the US, it actually works pretty well. And so the idea is to use the visitation rates as a proxy for recreation in the recreation service. And so in that particular case, the access to recreation is not taken into account, but we're working on this and want to include that in the model as well, because it's obviously an important part of the recreation service of whether people can access the recreation space.
So, so when you talk about the bias, is because it's not representative of the whole population that is there?
It's, yeah, basically not everyone takes a picture or posts a picture on social media data.
And you think this could also be biased by a range of ages, for example?
Yeah, yeah.
With the same experiment, they did it in Cayari, and then it appears that areas that are very difficult to access have high recreation value, but when they compare with their population, there is very old people there that mostly were not able to access that area, and you could be neglecting.
So, some of the, yeah, exactly. And well, we can probably take this conversation offline. I'd love to talk more about this, and the two colleagues who've developed the model have done quite a lot of work on this to better understand what you can extract from this biased or I guess incomplete picture of who is visiting the space, and there are other ways to do that as well with actual visitation from parks that they have used as well. In China, where we're working as well, they have now a system counting every single person going to parks, so they're using this instead of social media data, which in their case would not be Flickr, but there are also other ways to get at this information.
Great. Thanks a lot.
Mm-hmm.